Welcome to our comparison of inheritance and interfaces in Java. In this video, we'll delve into the nuances of these two fundamental concepts and understand when to use each. We'll start by defining what an interface is and how it differs from a class. Then, we'll explore the scenarios in which inheritance is more appropriate compared to using interfaces, helping you make informed design choices. We'll also cover interface inheritance in Java, showing how interfaces can be used to define a contract that classes can implement. Finally, we'll dive into the enhancements introduced in Java 8 and beyond, including default and static methods in interfaces, which offer new ways to enhance your interface design. Ready to master the art of choosing between inheritance and interfaces? Let's get started. An interface is a contract that defines methods without providing any implementation, requiring implementing classes to define the specific behavior of those methods. Interfaces differ from abstract classes in several ways. While abstract classes can include concrete methods alongside abstract ones, interfaces traditionally could not before Java 8, which introduced default methods. Additionally, a class can implement multiple interfaces, allowing for greater flexibility, whereas it can only inherit from one superclass. Using interfaces is beneficial for defining common behavior across unrelated classes, enabling multiple inheritance of behavior, and decoupling class design. This decoupling allows a class to focus on its specific behavior without being constrained by a particular class hierarchy, fostering more modular and maintainable code. When deciding between using inheritance or interfaces, it's important to consider the relationship between the classes involved. Use inheritance when there is a clear is-a relationship, such as a dog being an animal, which allows subclasses to inherit and potentially override behavior from a base class. On the other hand, use interfaces when there isn't a clear is-a relationship but you still want to define common behavior, such as a vehicle implementing a drivable interface where not all drivable entities are vehicles. Interfaces are also ideal when you need to specify behavior that multiple, unrelated classes must implement, as well as when you want to enable a class to inherit behavior from multiple sources, since Java permits a class to implement multiple interfaces. This flexibility promotes better design and code reuse in diverse scenarios. In Java, interfaces can extend other interfaces, allowing for the creation of more specialized contracts. This feature enables you to build a hierarchy of interfaces, where a child interface inherits the methods of its parent interface while potentially adding new ones. For example, consider a playable interface that extends a game interface. The playable interface could include additional methods, such as save game, to provide more specific functionality relevant to playable entities. This approach enhances code organization and reusability by allowing related behaviors to be grouped and specialized across different interface levels, promoting a clean and flexible design. Java 8 introduced default and static methods in interfaces, allowing interfaces to contain some implementation alongside the traditional method declarations. Default methods enable interface evolution by providing a way to add new methods to interfaces without breaking existing implementations. Implementing classes can choose to override these default methods or inherit the provided behavior. This flexibility ensures that interfaces can be enhanced over time while maintaining backward compatibility. Additionally, static methods in interfaces allow for utility functions that are related to the interface but do not require an instance of a class, further enriching the capabilities of interfaces and promoting better organization of code. As we wrap up our discussion on inheritance versus interfaces, we've illuminated key concepts that will guide your design decisions in Java. We began by defining what an interface is and its role in providing a contract for classes without dictating how they should implement it. We then compared inheritance and interfaces, understanding when to use each to best structure your code and manage dependencies. We explored how interface inheritance works in Java, enabling classes to adhere to multiple contracts. Finally, we examined the advancements in Java 8 and beyond, including default and static methods in interfaces, which add new dimensions to their functionality. With these insights, you're well equipped to choose between inheritance and interfaces based on your design needs, leveraging each to create clean, efficient, and flexible code. Happy coding, and may your choices between inheritance and interfaces lead to well-architected and maintainable Java applications.